During the walk-around, you will verify the condition of the drain masts, the pitot, AOA, TAT, and ice detection probes. You will also check that all of the static ports are clear and that covers are removed. In cold weather conditions, there are additional procedures for exterior inspection and ground de-icing, anti-icing. As part of the preliminary cockpit preparation, you should check that the wipers are off and the probe window heat push-button switch is set to auto. Note, in the auto position, the probes and windows are heated automatically after first engine start. Today, your takeoff is in icing conditions, so let's see what you have to know. Potential icing conditions are defined as outside air temperature below 10 degrees Celsius, visible moisture in the air. Note, the indicated temperature and visible moisture should be used as primary reason for turning on the anti-ice system without waiting for a visible ice buildup. The automatic function of the probe window heat system means that, in flight, the AOA and TAT probes, the pitots, the static ports, and the cockpit windows are heated. On ground, heating is provided when engine 2 or 3 is running, except for the TAT probes, which are not heated, and the pitots, which are only heated at low level. Note, you can clear the windows manually prior to engine start by pushing the probe window heat push-button switch to the on position. Because you are in potential icing conditions, the anti-ice system must be selected on. Please select the engine anti-ice system on. Select the engine 1 anti-ice.
Notice that the amber fault light in the engine 1 anti-ice push-button switch illuminates briefly during the valve transit. Then the fault light disappears and the blue on light remains illuminated.
As soon as one engine anti-ice push-button switch is on, the engine anti-ice memo and the associated ignition memo appear in green on the engine warning display.
The idle N1 is automatically increased to give better protection against flameout. However, N1 limit is automatically reduced. You can also note an increase of EGT and N2. Continue by selecting engine 2 anti-ice.
2 engine air intakes are now being anti-iced. Continue by selecting the engine 3 anti-ice. 3 engine air intakes are now being anti-iced. Continue by selecting the engine 4 anti-ice. The 4 engine air intakes are now being anti-iced. Continue the anti-ice procedure by setting the wing anti-ice system on.
Notice that the fault light in the wing anti-ice push-button switch illuminates briefly during the valve transit. The wing anti-ice memo appears on the engine warning display. The idle N1 is automatically increased. N1 limit is automatically reduced.
We have called the ECAM bleed page for you. Observe that the anti-ice white indications are displayed, meaning that the wing anti-ice push-button switch has been set to on. And the green triangles are displayed, indicating that the wing anti-ice valves are open. Observe that 30 seconds after the wing anti-ice push-button switch has been set to on, the wing anti-ice valve indications disappear. This is because, on ground, the wing anti-ice valves close automatically to prevent an overheat of the slats. This is the ground test sequence. At liftoff, the valves will reopen automatically and the slats will be heated again. Note, use caution when taxiing with engine anti-icing on, because ground idle is increased.
You are now in cruise, clear of icing conditions. If you do not expect the conditions to change, anti-icing systems should be switched off. Note: if no ice has been detected for 130 seconds, the wing anti-ice and engine anti-ice memos will pulse, with an ice not detected memo also displayed on the engine warning display. We have called the ECAM bleed page for you.
First, swing anti-ice off. Observe that the wing anti-ice message on the memo display and all the wing anti-ice indications on the ECAM bleed page have disappeared. Continue by switching off the engine anti-ice systems. First, switch engine 1 anti-ice off. Continue by switching engine 2 anti-ice off. Now switch. During climb or cruise, the anti-ice systems may also be switched off when the SAT is below -40 degrees Celsius, even if there is visible moisture. We are about to commence the descent. Because potential icing conditions are expected, the engine anti-ice system is switched on prior to starting the descent, even if the SAT is below -40 degrees Celsius. We will switch the engine anti-ice on for you. You are now in descent. The engine anti-ice system is on. You observe ice accretion on the visual ice indicator. We have called the ECAM bleed page for you. Switch the wing anti-ice on. Observe that the wing anti-ice indications are displayed on the ECAM bleed page. The wing anti-ice memo appears on the engine warning display. Note, because the engine idle speed is increased when the anti-ice system is used, the rate of descent is reduced. You are now taxiing to the gate. The wing anti-ice valves have closed automatically at touchdown, but the engine anti-ice will stay on until you switch it off, just before engine shutdown. Note, as the ground idle is increased, take care to control the taxi speed, especially on wet or slippery surfaces. Turn the wing anti-ice off. As the approach was made in icing conditions, do not retract the flaps and slats until after engine shutdown. Wait until they have been checked by ground personnel to ensure that they are clear of obstructing ice. Note, during extended ground idle operation, periodic engine run-up to 50% N1 may be performed to remove any ice from the spinner and the fan blades. For ground operations in heavy rain, refer to your FCOM.